Hey everyone, it is Dr. Patricia Dickenson, and welcome to my session, Let's Get Digital. We're going to be talking about creating digital lessons for mastery, and this is for the California Math Conference, November 6th through 8th, 2020. Let's get started. I am your presenter. Again, my name is Patricia Dickenson, and there's my cute Bitmoji. I am currently an associate professor of teacher education at National University. Maybe a shout out to all the NU alumni. In addition to that, I was a former elementary, middle school, and math coach for LAUSD, Los Angeles Unified School District. Another shout out for that. And I received my EDD in educational psychology from USC. Go Trojans. You can find me on Twitter at TeacherPrepTech, as well as on my website, teacherpreptech.com. Please give me a shout out. I have a podcast as well, and I'm always looking for bloggers as well as people to interview on my podcast. You can get access to our presentation here on this bit.ly at the bottom of our screen. So it's https://bit.ly/34V5Y capital L lowercase t. So thanks so much for joining me on my session today, Let's Get Digital, about technology and math, which has been a big focus for me for the past 15, 20 years. I love technology. I love teaching math. And for me, it's just a win-win marriage here, people, when we can combine digital tools. And like you out there, you're probably wondering how you can bring that marriage together in your distance learning classroom. So if you're looking to go the distance, you're in the right space. I've been teaching online since 2009, and it is certainly a different approach than we typically train our teachers how to be online instructors, how to really engage and captivate and design instruction for online learning. So we'll be looking at that, focusing specifically on tiered tasks. So those are tasks that support all learners because they have a low floor and high ceiling. So we can meet kids where they're at with additional scaffolds and support to engage, motivate, and create a wonderful online experience. Yes, it can happen. You can do it. And digital tools are supported by NCTM. In fact, there's a plethora of research out there, and that's why we have this wonderful quote from NCTM, which is, quote, "Students can develop a deeper understanding of mathematics with the appropriate use of technology. Technology can help support investigations, project-based learning, by students in every area of mathematics and allow them to focus on decision-making, reflection, reasoning, and problem solving." We're going to explore that, right? We're going to explore what that looks like with 5 specific strategies. So we'll look at project-based learning and problem-based learning. So kids are making a project with real-life application, and then problem-based learning is they're solving problems with a real-life context. Project-based tends to integrate other disciplines and allows students to create a product of learning, whereas problems tend to just focus on solving a particular problem in a specific context. We'll also explore what that looks like in terms of designing math instruction. I'm a big fan of UDL, Universal Design for Learning, but I also love the CRA model, which is the concrete representational abstract. We'll be looking at protocols for practice as well as open-ended tasks and assessment online. And just so you guys know, these are all hyperlinked to videos that I've done that really unpack these big ideas and allow us to go deeper with math. Why? Because we want our students to have mastery learning, which we'll look at in just a moment. But before we go there, I want to remind you guys that there's such a great plethora of research out there on teaching with technology. Piggybacking on our NCTM quote in terms of building conceptual understanding so students are able to understand what the concept means and make those deep, rich connections, understanding what a symbol or a representation represents in the real world, and to be able to think abstractly about those connections and apply them in a variety of contexts. So there's also been significant research showing academic achievement as well, and students being able to transfer their learning, going from pictorial pictures to symbolic algorithms, representations, with that concrete application. And students are more likely to spend time on task when using virtual manipulatives. They are motivated. We know that we can get them in the flow when they're increasingly using technology and designing and creating. So technology as a tool to really create a student-centered approach to designing instruction. Now, I have created a classification of tools that you are welcome to access everything under the sun that I have found and curated and been privy to getting access to. So definitely check out this tech tools tips and list curation that I've already created and are sharing with you. It's right here on my website, teacherpreptech.com. Just click on the link, Tech Tools. So let's talk about mastery, because this is what brings us to creating these digital projects and helping our students go deep with their learning. And so when we talk about mastery, we can look at what does it mean for our students to become and be mathematically proficient. So they have conceptual understanding, okay? They're being able to transfer representations in different ways. Procedural fluency, so they can do mathematics with automation. They don't have to go through the whole hem and haw drawing those visual models. They can do it mentally and they could do it efficiently. They know steps and computations. We're moving towards strategic competency now. This is another element of becoming mathematically proficient. And students have flexibility, so they can see a situation in multiple ways. They can do the area model and they can do the algorithm, right? They have strategic competency and they know why it works. Then we are moving towards adaptive reasoning. So students are able to explain their thinking and justify their solutions. And then they have the productive disposition. So this is kind of their like energy towards math, right? They have confidence. They're able to make sense of mathematics. They can see math as useful and worthwhile. So all of these pieces built together help our students move towards mathematical proficiency. And this builds on the Common Core mathematics, which is a balanced approach. So you can see a lot of those proficiencies are articulated in our 8 mathematical practice standards. And I should put a hyperlink here for those. If you're not familiar with that, I do have a video on my YouTube channel. I unpack each of those practices and what it looks like for both for the teacher in terms of supporting students and what the students will actually be doing. So it's just kind of this switch in thinking. But again, we want to make sure that we're doing both of these things. We're doing the conceptual learning, getting our kids to work with concrete representations and make sense out of, 1,000 block and being able to see it as 1,000 pennies and having those experiences if they need them, and they do need them to really get into that tactile representation. Then moving into procedural knowledge, like the standard algorithm for division, for long division here. But maybe they've already had those conceptual experiences where they're working with manipulatives and actually doing the algorithm of division with concrete representations. You can also do that with virtual manipulatives as well. So building on this idea of going from the concrete to the representational to the abstract, which is the CRA model out of the American Institute of Research, we want to build in these digital experiences because let's just face it, we are living in a digital world, people. from smartphones to smart computers to refrigerators that actually tell us what we need to eat. I don't have that right now, but I heard people do. We want to have these digital experiences infused throughout the CRA model. And there's so many great tools from Desmos to Math Learning Center where we can go and we can interplay between each of these three constructs, CRA. All right. So if you're not familiar with concrete, here's a group of my kiddos working on understanding volume by constructing a net into a box, finding the surface area, and then using unit cubes to find the volume. And they actually did one entire layer and then started building up layers before they realized, hey, we don't actually have to fill this entire box. If we know one layer and we know how many layers fit into this box, then we can determine the volume. And we did not even go into the formula yet. Let them discover the formula. That is part of the beauty of having those concrete experiences. A little article there I wrote about concrete and multiple means of representation. So representational, after they've had those concrete experiences, we can then move to representational where they're doing drawings. We just found out what the volume is. Now we're going to make a model of that. We're going to draw a net because we understand what a net is and what it represents. We've had time to do that. And we're going to build that. And then we can find different ways using both addition and multiplication to find out the total number of square units. Moving forward into the abstract, you can see why this can be so overwhelming for our kiddos when they're just thrusted into the abstract without having any of those experiences. Let them come up with their own procedural rules after they've had those concrete and representational experiences. And then again, looking at those digital spaces and having a digital task to let students show you what they know and make those connections between concepts is so revealing. This, when we talk about authentic assessment, here it is. You don't need to do photo math at all. You let them just show you what they know. So building that across those 5 dimensions is adaptive reasoning. So kids can move into adaptive reasoning using a digital tool such as Flipgrid. Love Flipgrid and giving them choice and voice by having them tell us where area is in their home and calculating that in any way that they can. So here's an example of what that looks like. Students are finding their own thing that they want to investigate, their own in their room, item in their room, and they're determining the area. Look, we've already had 469 views and we only have 14 students in the class. They love watching each other. Strategic competence, right? Again, this is the piece where we want our students to have multiple strategies and flexibility. So they're using a digital tool such as Padlet, where they're going on and they're getting a piece of graph paper and they're drawing their own irregular shape and they're labeling it and determining the side lengths. And they can use that in multiple ways. Then they're going to solve the equation for area and click and share their drawing. So we're giving them an opportunity to explain, to justify, to share their thinking, to show their knowledge in multiple ways. And if you haven't checked out Desmos, this is phenomenal. It also helps us give our students lots of practice with procedural rules, steps, computations, as well as getting into adaptive reasoning by explaining and justifying their thinking. Students can also develop conceptual understanding by seeing a concept such as unit rate in a video game. Click Battle is one of my favorite Desmos activities, and my students love it too because it's just like a video game and they're playing a battle and then they have to find the unit rate of the clicks. So it's fun. It's again, rooted in the lives of students. And we talked about those 5 competencies. And now we're going to apply it into project-based learning. Students can plan a camping trip and explore and discover things that are of interest to them. And you can design a task that builds on the mathematical competencies and skills you want them to develop a deep understanding, but also have opportunities to practice and develop procedural fluency. So I've created my student learning targets. They're going to use technology to create 3D models. They're going to calculate the cost of items, working with decimals, surface area, geometric shapes. They're going to get feedback from their peers. They're going to find the volume. So actually giving them opportunities to work across math concepts and not just in a silo of one particular math skill. And we can evaluate our students' thinking and their skills in a very authentic way, both in the area of procedural fluency, as well as their opportunity to model with mathematical tools and explain their thinking. So it's much more organic and authentic, even if we are working at a distance. Here's a fun activity that is actually part of this project. The students are given a table, but these, not with all of these answers, of course. We do explicitly model for them, so we could use this particular slide. Because we are working remotely, we don't have that opportunity to support them in real time at all time, but we can provide scaffolds. We can provide a worked out example of what we want them to do. And then the next slide would be an empty slide for them to work out their own problem. So the students are part of their camping trip. They are going to find a campsite that they want to travel to. They're going to determine the distance using Google Maps. And then they're going to determine how much money they would spend on gas by finding the unit rate of how much gas their car gets to, the car mileage lookup with the fuel economy site, and then they can determine how much money they would spend based on how many gallons they would need for their car and the total number of mileage for their trip. So there's a lot of higher level thinking that's happening in this one particular example, but as you can see, we're focusing as well on procedural skills, flexibility, and reasoning. All right, you guys can use that. I love this virtual graph paper. Part of the camping trip is they have to determine the area for their tent for each phase. So working with surface area. And the students in an earlier slide had to share how many people are going to be on their camping trip. And then we give them the size of the standard sleeping bag, so they would have to determine how big their tent would have to be. So a lot of reasoning, making sense of mathematics, and they can then go to this virtual graph paper and draw out their tent, draw out their net of their tent, and building their tent. All right. Another project that my students love is the holiday cookbook. They are creating a Google slide with several activities, from proportional thinking to dividing fractions, all in a holiday cookbook that they are crafting. And, if we were in class, at the end, they actually get to make their own gingerbread house, which was so much fun. And they would count the number of candies and do a decimal fraction percent chart with their candies, which they love doing, and share their thinking. So using the same tool, the students are using the line tool here actually to draw out their gingerbread house and finding the area of their house using formulas of area of a rectangle and area of a triangle. We can make them prove it in multiple ways. And then I can have some authentic assessment that my students have created based on how they've crafted their gingerbread house. So you can see how This isn't something you could just photo math or type into Google because it's an authentic task. Again, one of their tasks asks them to find a recipe on cook.com, and they have to scale up and scale down their recipe, identifying the original recipe servings and then double it and half it and triple it so that they get really comfortable with fractions, dividing and multiplying fractions. And we give them some scaffolds there with looking at this particular table. We can give them a worked out example and giving them exactly what we want them to put into our table here for showing us what they know. All right. Another activity, this is on ratios. We've provided them with a table with some missing numbers. They have to look at the picture. So we have a visual model and identify the relationship, label it, and determine if they're going to multiply or divide to write an equivalent ratio. All right. I also love creating my own virtual manipulatives, which are so much fun, especially when you are working with area models and visual models that students need to be able to do. You might not have the ability for them to do that without having access to concrete manipulatives, but you can make your own virtual manipulatives. And so we'll just look at what that looks like for this particular task of solving two-digit multiplication. So they're going to use the area model and they're going to first start with decomposing that. We do have a video in our particular slide deck. So that can be a reference. When you are creating these digital lessons, you should just include a short video of yourself explaining how to work through these models so that students can have a point of reference. This is called flipped approach to instruction. And so now that the students have actually broken apart or decomposed this problem of 36 times 15, they can then use the virtual manipulatives to create or have a representation of these partial products. So just do 30 times 10. These represent 100, so that would need 3 of them, 300. And 6 times 10 here, which is 60. You can drag across 6 tens. Okay. And now let's move to 30 times 5. It's going to be a lot. So we have 150 because 3 times 5 is 15. So I have 100. Now I'm going to do 5 tens. All right, and then 5 times 6, which is 30. And so after the students have gone through the process of actually building the area model, they can record their partial products. And then they would add all of their partial products together, right, to find their answer. Okay, so if you're curious about how to do that, there is a video. But let's explore open-ended tests. Here's another video that you can look at once you get access to this presentation, which will just cue you on how to create these open-ended tasks with your kiddos. But I want to introduce another tool, which is called Google Jamboard. And there's many wonderful ways that you can use a Jamboard to make connections, both for social emotional learning as well as for those 5 big ideas in developing mastery towards mathematics. So from both conceptual understanding to strategic competency to have actually creating a space for your students to have a productive disposition in math and provide them with a way to justify their thinking and explain their reasoning in a synchronous space. So here's an example of an activity that I did with my students. This was a fraction, decimal, and percent sort. This was their product. So when students are looking at this particular integer model, they're sharing how they're feeling today. And then we can have a discussion about rational numbers, having them put their own rational number on the number line that might not be there. And then the students are actually sorting these images that I've posted onto this fraction, decimal, percent sort. And we've gotten into discussions on have you ever used a fraction, used a decimal, or used a percent? So again, open-ended task, lots of opportunity for me to kind of assess and see what they know, where they feel comfortable, what connections they're making. And then based on that, I can reinforce some of those connections they already have in their own personal life and expand on that. Okay. So that's an example. Definitely check out the link down there. You can get that entire slide deck on Jamboard. And daily routine. So here's an entire series of routines that I've created on Math Jamboard to help your students practice procedural fluency, from anything on expanded form to writing equations to statistics and data. Anything that you want your students to practice can be placed onto a Jamboard as a daily routine to help build their fluency in numbers. Adopt a Pet is another math test that I've crafted for students. This was a 6th grade math standard where students are adding, subtracting, multiplying, dividing with decimals. Definitely check that out. Again, we're looking at moving these virtual manipulatives to provide an opportunity for kids to connect their procedural skills with digital tools. And so decimals is something that can be abstract unless you put it into a real life meaningful connection. Putting that all together, here's an example of a hyperdoc. So you have the Desmos, you have games like Sushi Fractions and Khan Academy and quizzes, all in one entire document for students to move through at their own pace. And this is critical for distance learning. The Design a Box Challenge, problem-based learning. The students work through a series of tasks. And definitely check this out. There are videos in there on nets, and there are 11 different nets that they can explore. We unpack the language of what a net is and then provide examples for them to create their own net through exploration tasks. We've also hyperlinked digital tools in here like CubeNets, which is on the NCTM site. So you create an all-in-one exploration in a digital project by modeling, providing scaffolds like tables and charts, as well as exploration of digital tools for them to go and explore and then come back and share their thinking. Choice boards. So every day, students can have a choice of the particular task they want to engage in. These are all aligned with your math standards. So definitely check out these choice boards for grades 6 through 8. And the students get to choose. They get to decide what task and show their knowledge. They can take a screenshot. If you're doing this through Google Classroom, then the kids would just submit their task. And more examples of virtual manipulatives. So the students can drag and drop these particular images into the table to show what they know about money and decimals. You can also build in your own answers so that students can check their answers and get real-time results, which is super motivating for the kids. It builds their efficacy and their productive disposition towards math because we're helping them make sense and seeing math as something that's worthwhile and has value in their lives. And they get to see their results in real time. So here's another video that I'm sharing with you all. It's a video on how to make virtual manipulatives. So a ton of resources, more tech tools and tips for creating digital math tasks for your kids to work with during this time of distance learning. And if you're interested in learning more about using digital tools and crafting math projects, click here and take a class with me. I also have a YouTube channel and a recent publication, The Virtual Classroom, Creating Distance Learning Experiences Math. This is for K through 8 learners. Thanks so much for checking out my presentation. Again, this is Patricia Dickenson, the Wired Professor, and I hope to hear from you all soon.